Hey, welcome. We are from Red Hat, and we are the open source and platform guys, just as we just have heard. Now, the big question is, how does it really relate to AI, right? So Red Hat AI was not really associated much in the past. So let's really dive into that together. So I encourage you to take out your smartphone, just snapshot this QR code, and use a very, very simple AI-based application that we have actually deployed together yesterday on a hands-on lab, just a couple of rooms next door, basically. So you're now going to consume AI, maybe not the state-of-the-art large language model, but it's still something that is super relevant to a lot of customers and organizations that we talk to. So one of the kind of messages here is that AI, loves open source, whatever that means, but open source is really the thing that enables AI. And like 30 years ago, when we started doing business, no one really believed seriously that open source would be a thing. But these days, open source is taken for granted, right? So let's have a closer look at what exactly is the scope, in which many ways open source is really playing into AI, especially when we talk about production, making really use out of AI. Of course, we wouldn't be here talking about ChatGPT, Copilot, so we just heard all the different ways how we're now interacting with large language models or generative AI, and how that's going to increase in the future as well. But AI is not just kind of what is now slowly coming out, but also a huge number of use cases across the industries, really. We're seeing AI now being deployed in factories, at several banks, and you get the idea. It's everywhere, right? So you can't really just pinpoint one industry out there. And it's extremely important for those organizations that AI is running reliably, securely, and so on. So when we talk about AI, we have this kind of tendency to focus really on the AI model. So that's the cool thing, the llama, the whatever out there. But there's a whole lot of infrastructure going on there, because another key message here, AI is many things, but AI is definitely software, right? So there's a huge kind of iceberg under the surface. So we're now going to take a closer look at what is actually out there that supports this whole AI notion. So another representation of this iceberg is this kind of boring stack over here. I won't go too much here into detail, but just to highlight, AI is software, right? So it needs to kind of consume hardware resources. These days, we need to kind of package AI pieces together and build them with dependencies. We talk about containers, and then how to run containers at scale, at large clusters of compute. How to automate software delivery, because as you just saw with that small application, it's software, it's an application. We have to be able to quickly build this, quickly update this. We have to integrate all the different pieces. We're talking about storage, obviously. We're talking about a lot of data that is now going into AI models. We're going up the stack. We're talking about now what the data scientists are really working on a lot. Of course, the data on the one hand side, the model on the other hand side. And we're talking then about the tools in terms of the languages and the developer tools and so forth, and the libraries and frameworks on top. And only on top of that is the AI model, basically, which is really based on that whole stack. There can be nothing that is missing there. So everything that is kind of under the AI model really supports that thing. So we can say, now we want to build this application that you have just seen with the object detection. Should we build all of this because all of this is important for the AI model? Well, of course, like Peter Drucker has also said, there is surely nothing quite so useless as doing with great efficiency what should not be done at all. Or you can say it more simply, don't reinvent the wheel. Spend time on things that really improve your business and not so much on things that are not really useful at all, right? So basic observation is that a lot of organizations, unfortunately, have a lot of time that their people, data scientists, developers, and so on, spend a lot of time doing things which are not so business related, kind of maintaining stuff that maybe can be maintained more efficiently. And they should really kind of focus, and that's one of the major movements here to focus on spending more time on the really valuable things, creating new cool models, for example, or build the applications which really kind of implement the business itself, right? So, cool. So let's just outsource the red stuff over here. And what has been really successful is that you can just outsource those things to the open source, right? So, especially when we talk about infrastructure, there are a lot of kind of problems and challenges that other people have also encountered, maybe in a totally different setting or so. But chances are there are pretty good libraries or packages that have already kind of been developed to solve that particular challenge, right? So the open source community is full of those great technologies and packages. Of course, we're talking about very small-scale open source projects of individuals, but also very, very large-scale ones, extremely complex software, but that has really become the state of the art out there, right? So we're talking a lot about collaboration, getting a lot of different people together, organizations, sometimes organizations that are competing with each other, just so they can together kind of get their experts together to advance the technology. As a byproduct, we create open standards, and of course, we are able to really solve such problems much, much faster. So what does it really mean for our AI stack, right? So, of course, when we talk about AI, open source, we're thinking about all those great libraries, TensorFlow, PyTorch, scikit-learn, and all the others. We're talking also about, languages like Python, R, all the nice developer tools over here. And we're talking about a very, very big and active ecosystem of tools for the different data stages, for the different modeling stages as well. But let's now go from the bottom. We're talking about software, right? Remember? That needs to consume compute resources, so there needs to be something that enables your software to really be scheduled on compute, whatever that means. So we're talking about Linux. Big success over here in terms of open source operating system. We're talking about CUDA for GPU acceleration. We're talking about all those cool new things with containers, with container management, to be really able to scale out processes, microservices, whatever you call them, to be able to really have a big application that a lot of users can use at the same time. We talk about a lot of the other stuff that kind of complements that for monitoring, for packaging, such kind of Kubernetes applications. We're talking about all the nice tools for automating building and deploying such small components. And definitely we're talking about, software-defined storage, for example, and integration pieces. There's a lot of routing going on. Maybe you want to have automatic encryption of requests. So not to go too much into detail here, but you just get the idea. It's a big stack, and open source is really everywhere here, right? So the kind of lower part, that's not something very new. So there have been platforms built around that just to make use of all the great stuff out there to get that together and enable people to use their tools, their parts of that ecosystem that they're really interested in. And what we're now seeing more and more is integration of other things sitting on top, really for data scientists and AI developers, building kind of on the lower part of the stack as well. So now we start really talking about platforms. We can say, well, great, there's so many cool open source projects out there. Let's now build our own platform to try to integrate all of those things. Turns out, one doesn't simply build a platform, right? So it's a massively complex thing, such a platform. So to give you a little bit of a picture here, think about a car. We can call it a transportation platform. And the essential business logic is that it gets you from A to B, right? So there's a kind of core piece like the machine learning model, which is the engine that really enables this thing. But you can't go anywhere with just the engine, right? So there are a lot of pieces around that you definitely need to do to integrate all of that stuff together. So of course, you can train your team to be able to really put all those pieces together. Of course, you're not only talking about movement, you are also talking about robustness, safety, right? You're thinking about people actually having to be transported somewhere. So there's a whole lot of stuff that you actually have to manage and integrate and test just for building a car, so it's not a trivial thing, and it gets even worse in software because all the small pieces there have a tendency to quickly become updated, so you have to make sure that the updates don't break anything. They don't break the whole car, for example, right? So big question is, how do we handle this? And I guess you know the answer.
Thank you, Max. So probably many of you who are here probably know that Red Hat started about 30 years ago with Linux. That was our first open source platform that we based our, in the end, enterprise offering on. And we are basically now at the stage where after 30 years and after having a lot of open source based platforms under our belt, we are basically entering into the era of AI. And there's nothing different when it comes to the way we develop our products out of communities. As was mentioned earlier, the communities are central to Red Hat. Actually, we have a upstream first mentality in engineering. That means that our engineers, when they write code, most of the time they write the code upstream in the community project. They are committers to different projects in the open source community. And then the way it works, normally we bring things together. Sometimes we bring projects from multiple communities into one umbrella project. That project itself is also a community that we sometimes manage or steer, and where you basically integrate things. And eventually we stabilize them on what we call our product branches. This is where we try to provide stability for our customers. We try to bring the power of open source to different industries which are very stringent in terms of security, compliance, and so on. And this is really pretty much what we do today when it comes to open source based AI. However, the important part to mention here is that everything we do around AI, us being more or less an infrastructure company, of course we have a lot of middleware and a lot of integration capabilities, but at the core of everything we do, including the AI platform that we're gonna talk about, is basically Kubernetes in the form of OpenShift, which is our productized Kubernetes distribution. Maybe some of you know it. It's our main contribution back to the community of Kubernetes. Basically, a lot of our work has been done in the upstream. A lot of the changes that our customers demanded from the Kubernetes to be a true enterprise-ready environment have been brought from OpenShift into Kubernetes. Eventually, many of the features that you see today in Kubernetes actually are coming from Red Hat. Talking to customers, working with them, making sure that the capabilities they need in their environments, in their different industries, are actually brought back to the community as requirements, and in the end, with the help of engineers, are implemented. So being what we call an open hybrid cloud company, basically our Kubernetes distribution, OpenShift, runs on all the different platforms you have today, from private cloud to physical, virtual data centers, to the public cloud. Of course, we have great partnerships with Microsoft, with Amazon, and all the other partners here. To the edge, where we have a lot of requirements for AI. There's a lot of devices, like you saw our simple application. You have object recognition at the level of a simple device that can point to an image, to a room full of people, identify faces, identify objects. So a lot of the edge requirements are really targeted towards AI, and this is an area where we also cover the capabilities when it comes to all you need to develop models or to run models while using a common platform, Kubernetes, in the form of OpenShift. So the way we basically tackle the AI requirements, the new world of ChatGPT, the way that everyone is looking at how can we implement AI using open source, using a capability such as Kubernetes, for example, such as OpenShift. So we went into this space coming from this background, and we used all of our knowledge, all of our experience that we built around this space in order to create a AI-focused, basically, portfolio, but running on our already trusted and tried OpenShift platform, which, of course, in turn is using Linux as the operating system. The AI platform basically is nothing more than how we created Fedora out of the community projects in Linux, and then out of it we created RHEL. Similarly, from Kubernetes, we went to OpenShift, and Kubernetes itself incorporates many projects. So for what we created, and that I'm sharing with you today, we had the same mantra, we have the same way of working. This is the Red Hat model for all the open source involvements. We basically have the so-called funnel, where we bring a variety of community projects that we work on with our engineers. We commit upstream the logic, the code, but we bring them together under a umbrella, in this case, a project called Open Data Hub, where we do all the testing, all the things that are necessary to productize and create a common cohesive interface, a UI that our customers can use, a platform that is cohesive, because as you can see, there's many different projects like Kubeflow, for example, for doing data science pipelines. You have things like TensorFlow, projects coming from IBM who committed to the community, things like Ray and the Cloudflare, Kserve in order to serve model to applications as APIs in order to incorporate the models you create. So do intelligent things like you saw in the app you saw earlier. And then, of course, there are IDEs like Jupyter that are very heavily used by those data scientists who are using Python. There's RStudio based for the R language, and so on and so forth. All of these things come from a variety of sources. There's great people behind them. But to bring them all together, the way Red Hat works in this space is we try to create a community on top of all of the other communities that can then be easily productized and can be cohesive. So that's the flow, that's the funnel that Red Hat does for every product since 30 years. There's nothing different for the data science. So the way we implemented basically some use cases, for example, Boston University was last year one of the first customers for this platform, and it's basically exactly in a university like this, they are trying to basically provide to the students notebooks in an intelligent way, all web-based in order to do their data science projects or even non-data science projects, but there is a way to basically deliver software in order to automate the whole processes around MLOps, around building basically models in a university, in the labs. We did something similar yesterday. We had a nice lab, a lot of participants, just to showcase how notebooks coming out of this Kubernetes-based platform can be used for students to do their homework, to do their projects for data science, for AI, and then publish their work, have them applications use this work in intelligent ways. Of course, everything we do is we do it with partners. And of course, we thank Accenture for inviting us here. And we find that Accenture strategy on AI is very well aligned with what we do. We need our partners. We are a vendor. We are a technology company that without our partners, we cannot easily reach our customers in the end. We have a large collection of capabilities in what we call our OpenShift data science. But of course, there are things that you can plug in very easily, things like Anaconda, things from Intel. Of course, we're using the NVIDIA GPUs, and they have operators running on OpenShift and Kubernetes to manage the variety of GPUs that are available for data science. We have a lot of partners that are coming from the startup community, like Starburst. They have, for example, a data mesh, a way to access data lakes and a variety of data sources that are crucial to train the model. So when you want to train a model, you always need a large amount of data. You saw how ChatGPT was trained for a long amount of time against a large part of the internet, basically. For those of you who are inclined to try things out, and if you were not at the lab yesterday, we invite you to take a look at our site, AI on OpenShift. It's a big collection of hands-on tutorials from running Spark on OpenShift to trying out our data science platform, trying to do data engineering, trying to create models. Basically, do the hands-on things that the geeks like, and you can see also a lot of patterns for data science, for creating models, for training models, refining models. You can see tools and applications that you can use for this. Of course, all these great community tools that you saw are coming with examples there. And there's also demos. So they're full of demos for different use cases. For example, object detection, threat detection, anomalies that you want to detect. There's a variety of use cases LLM, of course, that you might want to try it out yourselves in this site. And basically, the whole idea is open source for AI at scale with Red Hat. We thank you for your time.
Please join us at our booth later if you want to see and learn more about this, and of course the presentations by our dear colleagues later as well. Thank you.
Thank you, guys. That was Red Hat, guys, and that was really fast. And I'm really thanks that you made it in time. We have actually 5 minutes left. So, do we have any questions? Do we at least one question? Anybody has a question about this? Is anybody going to raise their hands if anybody is going to deploy in-house AI with Red Hat in like maybe next couple of months? Okay, it doesn't look very. You? Okay. Okay, she's going to. Oh, who's got a question?
How you are doing MLOps?
How are you doing MLOps on this platform?
So basically, everything about this platform is on MLOps. So we create data science pipelines. We automate the whole flow from training models, accessing data from models, all the way to producing a model and handing it over to an application to integrate. So we are basically, if you know Kubernetes or OpenShift, we are leveraging a lot of those capabilities. Things like Tecton pipelines, we are incorporating new things in the AI world like Kubeflow in order to automate the entire process for the data scientists. On top of it, we provide the IDEs, Jupyter, RStudio, where the data scientists do their work, and they can visually start their automated pipelines, their jobs, in order to generate their models or refine the models in the whole flow. Everything runs basically using the OpenShift infrastructure. The data scientists can access the GPUs directly in their data science pipelines. For example, they can have steps with GPUs enabled and things of this nature. You will see some other presentations from my colleagues today as well around this. And yesterday we had some nice labs as well, hands-on labs.
Thank you very much, guys, again.